that the members of the SEPS project come up with fantastic ideas. Okay, so basically it's an upgrading of the sorting system. Okay, and I think your idea is to use the modern electronics to upgrade the system.
Yes.
And I think this system is going to be very feasible.
Okay.
Because it will be less than $1,000 US. And apparently the Uganda government does have this budget. And
it's very good. Yeah, excellent. Well, a long time ago, perhaps a year or two ago, I remember reading in the newspaper one day, and it said, and it must have been, it's a bit like this, and it said, the simple way to disinfect water is to just put it into a bottle, you know, like the bottles we buy water in, mineral water bottle, just put it into a bottle, some dirty water, leave it out in the sun and filter it, just like you're doing. And it was suggested that this would be useful in, say, somewhere where there's an earthquake or something. You know, so there's lots of people, there's no water, the water makes it damage to them. Yeah, you just find an empty water bottle and leave it out in the sun. And what you're doing is doing it on a more organised basis. Because of course, these sort of things, like the plastic tanks and things, like a lot of things, if they're made in large quantities, they'll be very cheap, won't they? If you just, the nice thing about it is it's scalable, isn't it? So this one is a particular size, which feeds 200 or 300 people, and then if you need more, okay, you just get another one and add it next to it.
Yeah, you can.
There's no reason, no real advantage in making it.
I think this is a very good starting point, because as you have said in your report, you know, many people got ill or may even die from drinking infected water, and especially children. So I think if viable, this project would be very, very beneficial to people in Uganda. Of course, you know, the problem cannot be solved in one day.
Presumably in the software, you will put in something that checks that the sensors are working, and if there's a problem, so that if, for example, one of the sensors stops working, the software can recognise that and somehow tell you, you know, the maintenance is needed. So that if the temperature, because if the temperature, after all, if you've got 4 temperature sensors, you know that they should all be pretty much the same. And if one of them says it's totally different, probably it's failed. And similarly, the sunlight sensor, presumably, if you get no output from it, you know it's not working. And the software can recognise that as well. Perhaps there's a red light that just says.
Probably, you know, you know, the issue of clean water doesn't just exist now. It's an issue from the very beginning of the human history. Okay, so how did people solve this problem before? There must be some means, right? So I would encourage the members of this group to dig a bit of history, you know, to find out, you know, other means of getting clean water.
But you could use the whole thing as a sort of educational thing, couldn't you, for, you know, locally? You know, say there's a school there, perhaps the school looks after it, or it's on the roof of the school because the school's a nice big building, or it's in the school grounds because the school's got some space. You can use it to teach the children about, you know, the importance of clean water, the electronics.
So maybe I think that if successful, this project can be extended to other parts of the world, in Asia or in other poor countries where clean drinking water is insufficient.